Hello and welcome to today's class. We're looking at the concept of linear charge configuration. So last class I explained in-depthly on the concept of Coulomb's law, and I show you the vectorial form of Coulomb's law. Let's now look at the first concept there called the linear charge configuration. Last class I said this concept is about to 5 cases there. The first one is called the linear charge configuration. Second one is called the rectangular or triangular charge configuration. We have the square charge configuration and etc. Let's start the first one called the linear charge configuration. First thing to recall, please, I would like to recall back, although we said Coulomb's law, from the law of Coulomb's law, we know that force F is equal to KQ1 Q2 all over KQ1 Q2 all over R squared. This formula here is known as Coulomb's law formula. So this from Coulomb's law, by the way. So now I'll take this law in terms of vector, right? So I said last class that you have to be familiar with the concept of vector well before you dive into Coulomb's law in vectorial form. So I'm saying this now in vectorial form. In vectorial form, we can express Coulomb's law as being F this way is equal to KQ1 Q2 all over R12 magnitude all squared dot unit vector of R12. So these are still the same thing. This one here is Coulomb's law in neutral form. This one here is Coulomb's law in terms of vector, right? So I established this concept last class. So we'll take a quick problem under linear charge configuration. So we'll take a problem and we'll use that problem to explain how this concept works. So let's start with the example involved in linear charge configuration. Sample problem 1, it says two charges 15 microcoulomb and minus 21 microcoulomb are 85 centimeter apart. If a third charge 65 microcoulomb is placed midway between both charges, find the resultant force on the 15 microcoulomb charge. So that's all. So let's try to solve that question. So I'll take off this one. I'll take this off. All right. So first in science, after reading out the question, your next task is to list out what you are given. It says that two charges, 15 microcoulomb and 21 microcoulomb. By the way, a negative 21 microcoulomb are 85 centimeter apart. Now listen, please. When it comes to Coulomb's law in terms of linear charge configuration or in terms of any shape, here's the concept. Whenever I'm given a question, this question is given in word form, right? In word form. Your first task there is to draft out the diagrammatic expression. By the word expression, I mean you should draw the diagram of what the word problem is trying to say. Here it says that two charges, first, from Coulomb's law, we know that my charge are in this form. So it says that two charges, 15 microcoulomb, so my first charge 15 microcoulomb and minus 21 microcoulomb are 85 centimeter apart. So it means from here to this point here is 85 centimeter apart. Next task, it says if a third charge 65 microcoulomb is placed midway. If I say midway, that's like the center. So from here to here, the center, obviously, if I should pick a point, it should be the center. The center here, it has a charge of 65 microcoulomb. Next up, proceeding from there, it says find the resultant force on the 15 microcoulomb charge. So I'm asked to find the force, or perhaps resultant force on the 15 microcoulomb charge. Now listen please. For easy access, first task, convert 85 centimeters to what there to meters. So we deal basically with what meters. If I should convert 85 centimeters to meters, I should have about 0.85 meters. I have this place. So convert your centimeters to meters. First is first. That's the first task. Next up here, please. Look up, please. If I'm saying that year to year is of course 0.85 meters, that's fine. Please, if I have this one here, if I'm to share the distance from here now and this place here, what will be the exact distance from this point to this point, and of course from this point to this point? It's easy as what? Divide this man by 2. So I'm saying that if I divide this one by 2 here, I should have about 0.425 meters. Year to year gives this. Next up, I'll have 0.425 meters. It means that if I should add these two values together, I'll have a total of what? 0.85 meters. That's like the analysis I can do when it comes to distance. So I'm done with the distance and the conversion concept. Now, next task now is to identify your charges. I'm given 3 charges here. The first one there is 15, 65, and -21. First things first, identify or perhaps label those charges. So I'm saying this is my first charge, so call it Q1 should be equal to, or perhaps is equal to 15 microcoulomb. Next up there, this is my second charge, that's Q2 is equal to 65 microcoulomb. Finally, the last one there is Q3. So Q3 is equal to -21 microcoulomb. I have identified each charges. So Q1, Q2, and Q3. So I have this one here. So next task, please. Next task here. After identifying your Q1, Q2, Q3 concept, I'm asked to find resultant force on Q1. So I'm saying this, please. The resultant force on charge Q1 will be equal to F1 resultant, right, is equal to now listen please, listen. I'm asked to find resultant force on charge Q1, right? Charge Q1. So I'm saying that resultant force on charge Q1 is equal to, now I'm going this way, this to this and this to this. What do I mean? That becomes F1 2, that this is 1, this is 2. So F1 2, so that the force between 15 and 65 plus the force between 15 and what? 21, 1 and 3. So I'm saying that for resultant force is simply the sum of what? Each forces here. That is the first one that we're considering with this one. That same first one we're considering with what? With the last one. So I'm saying that F1 resultant is equal to what there? F12 plus F13. As easy as this, please. Now my next task now is that I will actually find the value for F12 and F13. So I will look for the value of what? F12, F13. If I get a value there, I'll put the value here and I'll get the exact value of F resultant, or the resultant force on charge Q1. Now let's get F12. So I'm saying this, please. F12, let's get F12, F12. What do we know? F12 can be expressed as K, can be expressed as K, Q1, Q2, of course 1, 2, Q1, Q2, all over R12 magnitude all squared dot unit vector of R12. So I'm putting this man in terms of vectorial form, right? This here is expressed in vectorial form. Now proceed for me, please. From this point here, now here's the concept. Your first task to get is to get your R12. That's your first to do, please. When it comes to the concept behind Coulomb's law in terms of vectorial form, your first solution, your first breakdown should be what there? R12. So I'm saying this, please. Let's get R12. So R12 is equal to, the formula is easy as, I have R, please pick out R and 1 and then pick out R and 2. So R12 is simply the difference between R1 and R2. So I'm saying this, please. The formula becomes R1 minus R2. That's the formula to calculate the position vector of R12. This is now equal to, now please, when it comes to R, we know that R is simply what the distance apart. That's all. So if R is distance apart, now listen please, we know that this one is position 1, 2 and 3. This man is Q1. It being Q1 means this position is what? At section 1, section 2 and 3. Now listen please, I'm asked to find R1. Where is R1? R1 is distance at section 1. Section 1 is here. There is no distance here. This is section 1. This starting point. A starting point is always what there? Always 0. So this starting point will be 0. So R1 is what? Is 0 minus, in a bracket please, what's R2? This is charge 2 here. So it means that from this distance from here to here is R2. So from here to here is what? 0.425. That's your R2. Now here's the concept, please. Go back to your high school, that's SS3. Go back to SS3, please. Go back to this popular known concept. If I have a graph in this form, please look up. This part is x. That's positive of x. Here is negative of x. Here is positive of y. This part is what? Negative of y. Please, if I have this one here, now listen, here's the concept I'm trying to establish. If an object is moving this way, the value should be what? A positive value. If the object is moving this way, it should be what there? A negative value. Upward, positive y. Downward, negative y. So now listen please, when it comes to vector form, if I'm moving horizontally, I'll be using the concept of I. If I'm moving vertically, I'll use the concept of what? Of J. Please bear this concept in mind. If I'm moving horizontally, I'll use I. Vertically, I'll use J. This expression was got from what? Vector. So please bear in mind that vertically goes with J, horizontally goes with there with I. Now listen please. Listen please. Let's get R2, please. For R2, this is my position 2. R2 means distance from R1 to R2, which is what? 0.425. I'm moving this way. This way here in your graph is this part here. So the value should be what? A positive value. So I'll have a positive value. That becomes, from here to here is of course 0.425. Now I'm moving in an x direction. For x direction, because what there? A I. Please, I. By the way, distance is in meters. So I'll have meters I. Why I? Because I'm moving horizontally. Either right or left. Horizontally, I'm using high. That's the concept. So I have this value as my R2. Solve this one here. I'll have minus 0.425 meters I. That's your R12. So R12 is equal to minus 0.425 meters. So I have this value here. Next task, please. Let's get the magnitude. I just got R12. Let's now get the magnitude of R12. The magnitude of R12 is easy as, please, when it comes to magnitude, just take the square of that term, your magnitude. You are taking the magnitude. So I'm saying this, please. I want to take magnitude of this term. So here's the concept. To take magnitude of this term, I have to take a square root of that term and square the value itself. What's the value here? This R12 is exactly what? Minus 0.25 meters. I will square it and attach a square this way. So for magnitude, simply take the square, simply take the square root of the term and square it. That's all. That's magnitude. Simply take the square root of the term and square it. That's magnitude. All right. If I should proceed from here, if I should proceed from here, if I take the square root of this term here, if I punch a calculator very well, this value should give me 0.425 meters because it's R and R is distance. So I have this value. If you punch this calculator, you have that value. Now listen. At this junction, I will say this and I'll skip it. Now listen, please. When it comes to something of this nature, the task is easy as there's a shortcut applied to it, please. If I have something of this nature, it's proper for this square, should cancel the square root and this minus is what? Is gone. So I'm saying this, please. If you get to this point here, just take the square root and the negative sign out and the square out. The value, this ones here, remains your value. You can punch your calculator. If you punch this value here, it will give you exactly what you're having here. That's like the concept behind this, please. So I'm done with R12 magnitude. So I've got the value of R12 magnitude. Now in your next task is, I said your first task in this formula, get the value of R12 and its magnitude. I'm done with that. Next task there, I'll have to find the unit vector of R12. So this stuff means caret, right? If you watch our video on vector, you should understand what this stuff means. So let's get unit vector of R12. So unit vector of R12 is equal to, from vector, its unit vector is simply the ratio of position vector all over magnitude of the vector. So I'm saying this, please. This man here is equal to position vector, that's your R12 in this form, all over the magnitude of that vector. So magnitude of what? R12. Please check. What is this value here? Of course, this, you can see this, these are the same thing. The value there is negative minus 0.425 as that value there. So in meters I, please, meters I all over this man here is this. The value is this. So I have 0.425 meters. What do we know initially from mathematics? This one here will cancel this one. Left is what? Negative I. So the value of R12 unit vector is equal to minus I. So I have a minus I. At this point, I will now input what I have as my value into this formula and get the exact value of F12, and that's all. So at this point, substituting, what do I get? So I'll try to take this part off. I'll take this part off, although we know Q1, Q2, Q3. This Q1, Q2, Q3, and that's basically easy to get. So take this off. All right. Let's get the exact value of F12. So I'm saying this, please. Recall we said F12 is equal to K Q1 Q2 all over the magnitude of R12 all squared dot unit vector of R12. So I'm saying this, please. This is now equal to what's K? K is a constant value, and that's 9 times 10 to the power 9. That's K. This K is this constant into what's Q1? Q1 is your first charge. That's 15 microcoulomb. That's 15 times micro is also a constant. That's 10 to the power minus 6. So times 10 to the power minus 6. That's for this one is here for Q1. Where's Q2? Q2 is this 1, 2, 3. This Q2, that's 65 times 10 to the power minus 6. Why this value? Because I'm having what there? A micro. So our micro is this value there. So I have K is this, Q1 is this, Q2 is this. So all over this man here is this one here. The value is of course this one. So I have to put this value below here. That's 0.425 in bracket. Of course, observe please. This man is just this alone. I'm having a square here. See square. I have to put a square. So I'll attach a square here. Square. I'm done with this. Next up, dot. By the way, dot means times. So we don't use this. This is outdated, right? So the current one we use now is just a dot. So it means times. So dot. This one here should give you this one here. This I have a minus I. So minus I was my value I had when I solved that value for this. So punch this. I'll have that F12 should be equal to, if you punch correctly, punch the value of all this one here, it should have the value as 48.58. So everything here on calculator, you give it this, right? So next up in brackets, I have a minus I. Force is measured in Newton. It's for force measured in Newton, it means that my answer now will be equal to 48.58. Force is in Newton. That becomes a Newton. Of course, I have minus I. Sorry. If I have 2 times minus A, this should give me what? Minus 2A as my answer. So here's the concept is, if I have this value here, this minus will come out first. So I'll have minus, because multiply this together, I'll have minus 48.58. Then force is in Newton, this I will be attached here, I. So the value for F12 is equal to negative 48.58 Newton high. I've gotten its value. Let's get F13. That's our goal, right? We're looking for, we said to get our final answer, we said F1 resultant is equal to F12 plus F13. I've gotten F12. Let's get F13 and put the two values inside this place and then sum them up to get F1 resultants. So at this junction here, I'll take this off. Let's get a value for F13. As illustrated, let's get F13 please. So F13 will be equal to, what do we know? That becomes K Q1 Q3 all over the magnitude of R13 all squared dot position vector of R13. All right, I have this place. So set your first priority, get R13 first. That's tax. Get R13. So for R13 will be equal to, it's easy as we said, subtract the first number from the second one. So I'm having what? R1 minus what there? R3. So this is like the formula for getting R13. Madam. Okay. Sorry. Huh? Yes. So let's get R13. So we said, by the way, we know that R expresses distance. Now here's the concept please. This is 1, this is 2, this is 3. It's clear. Now R1, yes, my 1. So it means distance at this point is 0. Why? It's my starting point. So here is 0. So I'll have a 0 here as the value for R1 minus in a bracket please. What's R3? Yes, 1, 2, 3. Distance covered from R1 to R3 is my R3 value. So from year to year is exactly year to year. The value is this. Please, I'm moving in this pattern. I just drew a diagram here, a graph this way. If I'm moving horizontally, now here's the concept. I'm moving in this pattern, not this pattern. I'm moving this way. I'm moving this way. So in this way here, my value should be positive, and also I'll be having my answer in terms of I. If I was moving vertically, I'll be having a positive answer here. Here will be negative y, negative x. So moving this way, positive x. This way, negative x. But if it's horizontally, I'll use I. Vertically, I'll use j in terms of vector. So for your R3 here, I'm moving from year to year. Year to year follows the pattern of what? Year to year. And my answer is positive. So what's the value here? This is from year to year is of course 0.85, 0.85. Of course, my R is distance in meters. So I'm having meters. So I have meters. Of course, I'm moving horizontally. I'll use the concept of what? I have I. Get your value here. I'll have multiply this by this. I'll have minus 0.85 meters high. I've gotten the value for what? R13. Let's get the magnitude of R13. Magnitude of R13. So the magnitude of R13 is equal to, we said magnitude is easy as taking the square root of that term and square it. That's all. So take the square root of this term, right? This term, this R13 is this value here. Take the square root of that value, this is the value here, and what there, and square it. That's magnitude. That's all. So we said without taking calculator to stress myself, the answer is what? 0.85 meters. That's all. We said you can try it. Check your calculator. Point this value. It will give you this. To save time, this one will cancel this. Negative will go off. I will left with this. So that's like the concept there, right? So next task here. Next task here. I've gotten magnitude, which is this value here. Let us get unit vector of R12. So unit vector of R12 is equal to position vector of R12 all over the magnitude of R13, please. R13, I have this, not R12. R13, this is not equal to this man here. The value is of course this one minus 0.85 meters high. So all over this one here gives this value. All right, that becomes minus 0.85 meters. So of course mathematically this one will cancel this. I'll have minus I left, as similar to what I had when I did the previous one. I had minus I. So I'm saying this, please. I'm saying the value now for the value for R13, please. R13 is equal to negative I. So I have minus I. Does not mean that does not mean that the unit vector must be always minus I. When I did the R12 concept initially, I had minus I. I did this one, I have, it does not mean that everything is minus I. There's a case whereby you have J, including your answer. So just bear in mind that it's not always high, please. So I've gotten all what I need. I now have to put each value inside this place here and get the exact value of R13. So and that's all. So let's get R13. Okay. R13, okay. Take this off. All right, let's get the value of F13, please. Not R13, F13, as you can see. So F13 is equal to, first K. What K is constant? That becomes 9 times 10 to the power 9, that's K, into, what's your Q1? That's charge 1, 15. All right, I have a 15 micro. This U is micro. It's not U, but let me just call it U, so that you're familiar with it. This is a constant value, 10 to the power minus 6. in towards Q3 is charge 3. That's a negative 21 times 10 to the power minus 6. All right, I have this. All over this one here gives this value, right? So I have this one is this. The value is this. So I have 0.85. By the way, this is square to this. So I have to put the square here. Dot this value that's minus I, as you can see, minus I. So I have a minus I. From here, if I'm to save time, point these all values here on calculator. You should have about correct. You should have a value minus 3.924. Right, everything here should give you, hold on, oh, this minus comes out first, all the value here gives you this, right? Then I have the I in this form. Get the exact value of F13. So I'm saying that F13 now, F13 will be equal to this same value down, that's minus 3.924. Please, I'm dealing with force. Force is measured in Newton, so I have a Newton, then the I will be attached to it. So the value for F13 is minus 3.924 Newton I. So let's listen please. I've gotten F12, I've gotten F13. Let's now get a value of F1 resultant. It's easy as what? Add this answer to the previous F12 answer, and then that's all on this example. So let's get a final answer. Let's get F1 resultant. F1 resultant. Let's get F1 resultant. So recall that we established that F1 resultant, that is your F1 resultant, is equal to, or okay, it's okay, or is equal to F12 plus F13. If you take a time to check your note, the value for F12, check your note there, it should give so what I had here was minus 48.58 Newton. Okay, sorry, Newton high. I had the value Newton high for this one. Check your previous note. Check a note. You see this plus this one here. I have not cleaned the board. I have it here. So put inside the value there minus what? 3.924 Newton high. So if I'm to solve this here, this is now equal to this, repeat down, minus 48.58 Newton high plus minus will give minus. So I have minus 3.924 Newton high. If I'm to solve, point this on calculator, I'll have the value to be equal to negative 44.65. Of course, Newton I is common, so I have Newton I. So the value for F1 resultant is equal to negative 44.65 Newton high. So that's the value for F1 resultant. So here is what to note, please. In exam, listen, I was asked to find the resultant force at charge Q1. That's your Q1 here. They can ask to find charge Q2 and charge Q3. So all we did now is like 1/3 of the answer. So we still have like 2 more procedure this way to get all the net force of this diagram. So I'm saying this, please. I'm asked to find the resultant force at charge Q1. What if I'm asked to find charge Q2 and charge Q3? That becomes a huge solving, right? And we expect that 20 minutes you are done with this question in exam. 20 minutes you are done with this. So here's the concept, please. Here's the concept. We are asked to find charge Q1. I'm done with the concept. Let me show you something by solving charge Q2. Let's assume that I'm asked to find resistance force at Q2, for instance. I want to explain something, please. Let's say I'm asked to find the force at charge Q2. So that becomes F2 resultant. This was F1 resultant because I'm dealing with charge Q1. So let's say I'm asked to find charge Q2 now, for instance. That becomes F resultant is equal to F21 plus F23. It's easy as this one here with this one here with this. So this is 1 2 3. So 2 with 1, as you can see, and that same 2 with 3. Why? Because I'm dealing with 2. Now the concept, let's try to get F12. This one, this yourself. Let's get F12. I'll try to show you some relationship, please. Let's get F12. To get F21, to get F21, it's equal to, it's easy as your normal procedure, your K first, K, Q, 2 was here first, so 2 first, then Q1. If I write K2, if I write K, Q2, Q1, it's correct. If I write K, Q1, Q2, it's still correct from the commutative law of mathematics. So that law works with addition and times. So if I have 2 times 3, this man gives me 6, right? If I swap it, 3 times 2, I still have that same 6. It works here. Let's say I have 2 plus 3. This gives 5. 3 plus 2. This gives 5. So when it comes to times and addition, irrespective of the position of the numbers, it gives you the same answer. So I'm telling this, please. I can either put Q1 here and put Q2 here, or follow the pattern, that's Q2 before Q1. So all over the magnitude of R21, please don't change this one. No, those I said Q1 can come for Q2, and you now come and put R1, R2. No, this one here should always follow the pattern of the question. So all squared dot unit vector of R21. Let's get the value for this, please. Let's get the value for F12. I want to establish a concept. Let's get F12. So from here, first is first, get this first. So R21. Let's get R21. R21 is equal to R2 minus R1. R2 is our first distance here. So R2 is at this point here, center point, that's 0. So R2 is 0 minus, in bracket, what's R1? R1 is here. So I'm moving what? In a backward way. That becomes what? Negative of x. That will give me negative. Why? I'm moving in a left direction. Negative of what? What's the value here? Minus 0.425 meters high. I have this. From here, minus gives plus. So I have 0.425 meters high as a value of what? Of R21. I have this place. Next up there, get the magnitude of R21. So the magnitude of R21 will give you, we said it's easy as what? Take the square root of that term and square it. That becomes 0.425 all squared. We said the answer is that term. So my answer is that value, 425 meters. So I have this place. Now let's get unit vector, and then we're done with the illustration. So let's get unit vector. All right, let's get unit vector. So unit vector, this one here, unit vector of R21 is equal to position vector, that's R21 all over the magnitude of R21. I have this. All right. This equal to this one here is this. The value is this. So I have a positive 0.425 meters high. This one here is this, and the value of course is this one here. I have 0.425 meters. This one here will cancel this. I have I left. So my value for R21 gives me I. So of course it's not minus I here now, it's not high. So it doesn't mean that everything is minus I, because I have I here in this case. Now from here, let's get the value for F12. So I'm saying this, please. F21, please. F21 is equal to K first. And what's K? 9 times 10 to the power 9. That's K into Q2 is this value. That's 65 times 10 to the power minus 6 into Q1 is this man here. That's 15 times 10 to the power minus 6. All right, all over this one here is this. I can see this one is this, and the value is this one here. So I have 0.425 all what there, all square. Please, this is square here, this is square, then dot. The value for this one here is I. So I have, all right, I have I. So if I punch all these values together, what do I get? So if I punch all this value together there, I should have a value of about, let me take off this. So the value should give me, so I have, so everything here should give me 48.58. So everything here gives me this, right? So by high, so of course this is force, Newton I, that's by the way. So my F1 to F21 is this value. Now at this junction, what do you observe? Initially I've got the value of I've got the value of F12 and I got F21. What's the difference between them? Observe that your F21 gives you positive, F12 gives what there, a negative, but at the same answer. So I'm saying this, please. I'm saying that the F12 that we did initially gives us minus 48.58. The F21 I did now, F21 gives what there, a positive, that's 48.58. So here's the concept here. So if I'm asked to find F12, I don't have to stress to get F21 again. No. If I get the value of F21, if I get the value of F21 as this, to get F12, don't stress. Repeat that same answer and add negative to it, that's all. So in a general sense now, I'm saying this, please. In a general sense now, I'm saying this, please. I'm saying that, so if you get the value of F21 should give you the negative of F12. So my F21 gives me this. But check your book. F12 gives what? That same answer but minus. So if you get F12, don't look for F21. Don't stress yourself. You repeat that same answer, add negative to it. So like one of them gives you the other. Right? So if I get F21, to get F12, just put minus. That's all. If I get F31, to get F13, just put what there, a minus here. That's like the concept behind this stuff here. So in exam, you can be asked to find the resultant force of all the components. So I'm saying this, please. I'm saying that for F1 resultant now, that becomes F12 plus F13. Let's say I'm also find F2 resultant. So F2 resultant gives F21 plus F23. Finally, Let's get F3 resultant. F3 resultant gives F31 plus F32. Now here is it. If you are asked to find everything in exam, the man or perhaps lecturer don't expect you to get F12, F13, F21. No, you are taking your time. So the task is it. He expects that you should know that all I'm looking for is just this, this, and then F2. Okay, F21 gives you the value of F12, 32, 23, and then 31. So you are just looking for just these three values. If I get F21 value, to get F12 is not hard. The value that I got here, just put negative, you get this one. If I get the value of F32, to get F23, it's easy. The value I have here, repeat it here and put negative. That's all. So for this one here, if I have an answer here, put it to get F13. If I have F31 answer, to get F13, just add negative answer to it. That's all. So in general sense, if I have to find everything, go for 1, 2, and 3. That's all. The others here I've got from these ones here. That's like the concept behind this linear charge configuration. So next class we'll look at the triangular charge configuration in our next class. So if you found this class helpful, do it to like the video, share to your friends and classmates, and subscribe to my channel. To enjoy more of these videos, you can visit my website at www.ganiyuabubakar.com. So in my website there, you can get access to these videos, a lifetime access. And also, I just launched a book called The Shortcut to Academic Success. To get a book, I'll drop a link in the video. I'll drop a link below description. Click on the link, it take you to a page where you can make your payment and get the book. All right, see you in the next class, and welcome to Excellent Link Academy.